All right. So we know what we want the problem to do. Let's take a look at our code. So the first things first, we are going to enter our number of rows. So this is, and our number of columns. This is how big our map is. And when we look at our map, remember up here at the top, this is a 1, and down at the bottom, that's a 20. So if you want to move up in position, then you're going to have to decrease that number. So it's a little kind of counterintuitive, but we'll get to that in a minute. All right, so that's our map size. And then our start row and start column, that's going to be our starting position. And we're going to have 2 vectors, one for the X position of our fire and one for the Y position of our fire. And those 2 vectors will always keep track of where the fire is in our program. Right? And initially, the values of those 2 vectors will be start row and start column. Okay. And then the number of trials, of course, that's just as if we want to do more than one. And then if the outcome is a 1, what does it say? If returned, outcome will be a row vector of length 5 designating the percentage of trials that resulted in such outcomes. For example, the value outcome 5 is the percentage of trials that burned out. All right. Well, we'll get to that in a minute, but let's start with our color map. Okay. First thing we're going to do is we're going to create this array for our forest here. Okay, forest. Forest is, this is our memory of the entire forest. This is what we're going to update, and all of our information about the forest is going to be contained in that array. And we start off initially, and we just say forest is equal to an array that has values of all 1s. And it's the size, it has a number of rows here specified by the user, so maybe 20 rows and then 20 columns. Okay? And this array is the thing that we're always going to be changing. Okay? So that's our memory. Right? In a video game, there's this world inside of the computer that has all the information stored in it. It doesn't matter what game it is. This is true for any video game. And that's what forest is. That's our world. All of our data is contained in there, whether it's a burnt tree, it's a green tree, or that's where the fire is. Okay, so this is our array, and here in outcome, then this is going to tell us, right, what the different possibilities are. So the first one is how many times did it go to the right? How many times did it go to the bottom? Then the third place is how many times, what's the percentage it went burned out on the left, and then the top. Okay, so initially we say fire row and fire column. Those are the current position of the fire. And everywhere in the program, that is always the latest position of our fire. And so those will, as the fire moves, we're going to update fire row and fire column. Right? So initially, we set fire row and fire column equal to our starting values. So our start row and start column. So this will be our starting position. Is the starting row, is that our X position or our Y position? If it's a row, is that X or Y? So we've got columns and rows. Which one is X and which one is Y? Which one is it? Is it X? Because rows, that's like we count down from the top, right? Do I have a piece of chalk? Oh, there's the chalk. Hey, so here let's make our forest here. This is our array. This is our forest. Hey, it's a beautiful forest. Hey, so everywhere in our forest is a one. These are all beautiful trees, they're green. Climate change hasn't destroyed them yet. Everything's green. Hey, so here's our lush, beautiful forest. Then we start a fire here. We'll say our fire starts here. 2. This one's on fire. Right? So if we say number of rows, well, row 1 is up here. This is row 1, and then 2, 3, 4, 5, and 6. So if we're talking about the number of rows, that's our y coordinates. So start row, or what is it? Fire row. Yeah, fire row. Fire row. This is our y position. That should be y. Okay, so fire row is our y position. Where is the fire in terms of y? Fire column, that's our x position. Because our columns go 1, 2, 3, 4, 5. Yeah. Okay, so fire column, this is x. Fire column's x. Okay. So we've initialized everything and we say, and now our forest here, right? This is our array, right? Here, this whole thing here, this is our forest. This is our memory. This is everything that's happening in our world. It's all in this array called forest. And so we're going to index it, right? Because initially when we create this, everything is 1. But I can index this and I can change one particular value in my array here. So let's say I want to change this to 2. I'm going to start my fire right here. This is where my fire is going to start. So I say, okay, that is row number 3, and it is column 1, 2, 3, 4. So I'm going to say fire. This is my map. And I said, I want to go down 3 rows. So row number 3 and column number 4, I'm going to set this equal to 2. So then 3 down and 4 over. Now I've changed this to a 2 right there. That's how I did it. Hey, that's the command. All right. So we've initialized our array. We started our fire right there. Row 3, column 4. Now, this while loop, this is the guts of your program. This is where all the magic happens. It's all in this while loop. And we have a big condition here to determine if we should keep going. Okay? And in our while loop here, we say all this stuff here, this has to be true. As long as all those conditions are true, everything after while is true, the program will keep running. So what are our conditions? Well, if fire row is greater than 1, okay? So fire row is greater than 1. And I lost my chalk. Oh, there it is. Right. A little chalk. Okay, so if fire row is greater than 1, that means it's below here. It has to be greater than 1. So it's either it has to start at 2, and then it has to go, it just has to be greater than 2. Our next condition is fire row is less than the number of rows. Okay, so that basically means if it's between here and here. What happens if I get to the edge? What does that mean? Well, that means our fire reached the edge of the forest, and so that was it successfully made it to the edge of the forest. Right? So if the fire reaches the outer row or the outer columns, right? So if it reaches right here, right, then that means that it made it out of the forest. Okay. That's why we use the less than and or greater than sign. If we chose, if we said wildfire row is greater than or equal to 1, right? That would mean it could be in the first row, but it would still keep going. So we don't want that. We only want it to, we want the program to run until it gets to the outer, to the edge, basically. And then our while loop is going to stop. Okay, so we've got if fire column is greater than 1 and fire column is less than the number of columns. Okay, so we've got our conditions for our while loop. All right, questions about this Boolean statement. It's a big Boolean statement. We've got some ands here. Every time we have a new condition, we got to do the double ampersand, which is and. All right, so we got and. All right. Now, this is a new vector. Okay, so this possible array, it keeps track of allowed moves. Okay? This is really important because this is going to tell us where we can go. Where can we go for our next move? Okay. Well, on the first one, we're right here. We can go anywhere. Right? Let's say our fire moves over here. Right? So it moves to the square. Now this one is going to be 2, and we need to update this value to a 3. Right? So we turn this tree into ash. So 1 equals tree. 2 equals fire. That's where the fire is. And then 3 is equal to ash. Our tree has been burned. It's not a happy tree anymore. Okay. So then our vector here, possible moves, this is going to check what's possible. Okay. So first, our first if statement here, we're going to look to the north. Okay. So we're telling Matlab, hey, Matlab, check what's above the square, fire row, and fire column. Okay. We talked about fire rows are y coordinates. Okay, so if we're looking to the north, then for right here, we want to say, what's to the north? Can I move there? Well, yes, because this is a 1, and so it's a tree, so I could move there. That's an allowed move. But then I say, if I move can I move to the east? Now I say, no, okay, because there's a 3 there. That means that tree is already ashed, and I can't go back there. Okay? And that's our condition here. Because we say if forest, this is our array forest. Okay? So our array forest is a map of our world. We're saying our current position is fire row and fire column. But I say if fire row minus 1 is equal to 1, I can move there. Right? That means right? I could move to the next place. So I say yes. Okay, so possible moves equals possible moves plus this n on the end. Okay, so what is possible moves going to look like? Well, let's make possible moves. So when I do these if statements, if I'm right here, okay, so I could move north, I could move west, or I could move south. So if I'm right there, then possible moves, this will be possible moves, okay? This vector would contain the values. I've got it. And I can move north, I can move south, and I can move west. And that's what's in possible moves. Okay? And each time you go through the loop, or you go through this process, after we move to a different square, possible moves is going to get written over. Okay, so let's think of this like a temporary vector, and we only are going to use this every time we go through the loop. We're just checking around us, and so every time we go through this loop, this is going to be updated. All right, like imagine if I'm the fire. Okay, so I go here and I say Oh, look, there's even squares right here. Huh. Okay, so I'm on this square, and I can go north, east, or south, but I can't go west because there's a table here. All right, so I'm gonna go north. Now, I can go east, I can go west, and I can go south. But I can't go north because that's not a full square. And so every time I move, this vector is going to update. So here, I can't go south because the table's there. I can't go north, but I can go east or west. So every time my fire changes position, then my vector possible moves is it's going to tell me which way I can go. Have any of you guys ridden in a Tesla with the autopilot? Well, I took an Uber and the guy had a Tesla and I was like, ooh, put it in the auto mode. I want to see what it's like. Well, it wasn't really exciting because it just drives the speed limit and doesn't hit things. But the robot was driving the car or this, whatever, the computer, right? But the computer, it has to check. It says, oh, can I change lanes to the right? Or can I change lanes to the left? If those places are empty, then that's okay. Right? So if you're driving in a Tesla on autopilot, the Tesla's doing the same thing. Right? So this is important. Right? All right. So all this stuff here, we are checking each direction. All right. So here, look south. Okay, if we're gonna look south, then we're gonna say fire row +1 because +1 means we're moving downwards. Okay, because on our map here, 1's up here, so if we want to move downwards, then we have to look down here. So we say, if I'm at row 3, add 1, and that's checking down. Okay. Okay, so we've got our possible moves. So we check in all directions. And if it doesn't equal 1, then it's not a tree, so we can't move there. Okay. So we build up this vector possible moves. It has all the information about how we could go, right? And it only stays there in each iteration of the loop. Then we write over it again. Okay, so this is not a variable that we keep for a long time, but we say, all right, if length of possible moves equals 0, what does that mean? If length of possible moves equals 0, what would that mean? Can't go anywhere. So what would we, so there's nothing stored in here, right? Because everywhere we looked, there was no possible move. All right, so let's say our forest fire has been going for a while and somehow it ended up like this. So we're all surrounded by 3s here. Right? Then, and maybe, I don't know, somehow we got this funky pattern like this. Right? So when as the fire looks around it and says, where can I move next? Well, there's no 1s around me, so there's no possible moves. That's the end of your program. Right? It burned out in the middle. Hey, and this is really important. So how do you kill the program? Well, this is how you do it. So if there's no possible moves, then we write the command break here. So this kills the while loop. Okay? It kills the while loop and the program's over. Or at least this part of it's over. All right, so kills the while loop. All right. And so we use the vector possible moves to tell when the fire burned out. Okay, so checks to see when fire burned out. That's how we do it. That's how we check. We have to have some way to know when we can't move anywhere else. All right. But now we actually have to move this thing. Okay. Right, because once we get to this place, then there's nothing else we could do. So this whole while loop is going to end. Okay. And so our outcomes, well, we didn't update our outcomes. Right, so outcomes starts with a vector full of zeros. So there's 5 positions, right? And it says individual trial will have one of the 5 outcomes. Right, so it'll reach right, bottom, left, top, or burns out within the grid. Okay. But now we have to move our fire. Right? We figured out what's possible, but now we have to actually make it move. Hey, well, so what happens when we move our fire? If we go to a different square, let's go back to one here. Okay. So our fire has moved 1 square, moved from here to here. And now when we if we go to this square over here, so we go over here, a couple things have to happen. Right? First, we need to update fire row and fire column. So we need to change the position of where our fire is. And we also need to write to the fire array. Right? So if our fire goes from this position here, first thing is we need to change this to a 2, and we need to rewrite this to a 3. Right? So each one of those steps needs to occur because there can only be one position that's on fire, right? We only have one forest fire. Okay. And so thinking about this homework, right? All right, so here's our move index. And let's see. Pick an eligible direction uniformly at random. Okay, so here's our move index. And here is our move. So possible move. So we'll say possible moves, move index. Okay, remember possible moves. It has a string inside of it. Okay. And so we're picking one of those random directions. Okay. So first we have to make an array of all the possible moves. And then we have to choose one at random. Okay. And so this move index, this picks our random direction. So this picks our random direction. Picks our direction. Okay, so we've got our vector possible moves, and we say, what's the length of our possible moves? Okay, well, if there was only one possible move, then the length will be 1. If there's 2 possible moves, the length will be 2. And so rand I, we say, generate a random number between 1 and whatever the possible moves are. Okay, so here, let's say our possible moves are north, south, and west. All right, so if I say length of possible moves, hey, this is going to give me a 3. Right? That'll give me a 3. And then if I say rand I of 3, it'll give me a value between, it'll either be 1, 2, or 3. One of those will be my choice. Hey, so then move index will either be 1, 2, or 3 for this one. And so then now I'll say possible moves, move index. Okay, so my move, what kind of value is the variable move going to have right here? So it's going to be a number or a string. what will end up being. Right? Because this is the tricky part. We're trying to get inside of the brain of Matlab. What is the computer thinking? What's it doing at this point? Right? So in a way, you're sort of right. We want to run this code in our mind a little, well, not the whole thing, but this line. Okay. So I say, first, what's the length of possible moves? Okay, well, it'll be between 1 and 4. Let's say it's a 2. Right now I'll say rand I2. So I just get a number. So move index, this is just going to be a number. Move index will be a number between 1 to 4. And then I'll hear possible moves. What kind of data was in possible moves? Those strings. Okay. So possible moves was strings. And now I'm going to pull out one of those values. So what does move have to be then? Yeah, move's going to be a string. So that will be a string. So I'll say string of direction. So it'll either be north, south, east, or west, based off of what's possible. But it's only going to give me a possible value for this one. Okay? And this is basically, we're doing the whole problem. Okay. So now move is equal to a character. It'll either be north, south, west, or east. Okay? And then now I've got each one of those situations here. Okay, I say, so if move equals north, okay, now I've got this first line. Okay, I say forest of fire row and fire column. That's the current position. Okay, I'm going to change that position to ash. So I update it to a 3. Okay, so this sets current position to ash. Okay, so it changes it to a 3. So this makes it gray on my color map. Okay, so if I update the current position to position 3, it changes it to a 3. All right, so it got trapped there right in the middle. So it got stuck in the middle. It looked around and said, there's no possible moves around me because everything's a 3 in my forest vector. Okay, and we can say what is forest right now? All right, so forest is, it's a big array. Everything is a 0. Right? Okay, well, I don't know what happened. Well, all right, but don't look up here. All right, but in my program, hey, that's a 3. Hey, so I've changed it to a 3. That means it's ash. And now I say, if it moves north, fire row equals fire row minus 1. All right, so if I'm here and I want to move north, I say fire row minus 1 moves me up to there. Right, and I set this new one equal to 2. Okay, so I said fire row equals fire row minus 1. And now I've updated the Y position of my fire. We'll say updates Y position of fire. And this sets new position on fire, or it gives it a value of 2. Okay, so I update my position of the fire now. And so the fire has moved up 1 and it has a 2. And then where it was is a 3. Okay. So, and I use else if for each of these. All right. The first one is if. Then every other position after that is else if. right? And then that's basically the end, right? Oh, and then we record our outcome. Okay. So if fire column equals the number of columns, right? Then this is important because we're recording what happened now. Right? So and let's see, where does this? Oh, yeah. So this end, right? That's the end of our while loop. Right? So we've reached the end of our while loop. And now we need to figure out what happened. Right? And the values number columns or fire column and fire row, those variables still contain the information of where the fire was because we initialized them before our while loop. Okay? So fire row and fire column, we specified those before our while loop. And so they still have that information there about what happened. What was the last position of our fire? Okay, so when our fire eventually reaches the edge, okay, so when it reaches this row, okay, in our while loop, okay, so we had while fire row is greater than 1. Right? Well, if it gets to this position here, so let's say eventually it gets up here, right? Then fire row is not greater than 1 anymore. Right? So that means our while loop exits. It's over. We put a break in it. Right? And now we have to update our outcomes. Right? So we say, all right, outcome 1. Remember, outcome is an array that contains all of our results. So let's go back up to the tippity top. And it says we're going to have 5 outcomes. Okay. 1, it reaches the right edge of the grid. Outcome 2, it reaches the bottom edge. 3, the left edge. And 4, the top edge. Okay, so then outcome is an array. An element number 1 in outcome, that means it reached the right part of our grid. So let's check. Is that right? Okay. So check to see if it reaches the right side. Yeah, okay. We've got outcome position 1, and we say if fire columns equals the number of columns. All right. So the number of columns, there's 1, 2, 3, 4, 5. And let's say I ended up here. So my fire reached this position. Right? Then fire column, its last position, fire column, will equal 5, which is also the number of columns. Okay. So now I've updated the number of columns. Right? So I said, yes, it reached the right side. I've updated that first space. Let's see. Did it make it to the bottom? All right. Well, if fire row equals the number of rows, it made it to the bottom. And then I say, okay, outcome, element 2. I'm indexing my array here. So say indexing array outcomes. Element 2 is if fire reached the bottom. Okay. And so now I've updated the array outcomes, and up at the top here, that's what I'm returning to my user. Okay. So let's try it for a number of simulations here. Let's say, I will say outcomes equals new fire. And I'll do 20 times 20. And I'll start it position 10. So row 10, column 10, and I'll do 100 trials. And I made mine so it plots every time. Because you were supposed to not do that, but I did it anyways because I like to watch the movies. Oh, okay. So here's my results. Right? Then I've got each of these. So it burned out 24 times, and then it made it to the right 21 times. It went to the bottom 14 times. Okay. And that's basically homework 6. Well, that is homework 6. Okay, well, let's take a break. And then we're gonna make a video game. Or we'll look at a video game. We'll make Snake. So 5 minutes.
Oh, it's fine. The question is about the exam.
Yeah.
Second one. So here the question number 3. The script should analyze with the first 2 terms. Like, where can I get these 2 terms actually? Like, because the user just choose
So the first 2 terms of the Fibonacci sequence are like 1 and 1.
1 and 1. Yeah. Oh, so and n is like how far
Yeah.
I should go.
So how many terms do you want? So you
Okay.
could do like 100, 1,000. Yeah.
And here in number 4, when user enters screen, like it says it should choose a number of characters. What does it mean?
Characters. So like,
Yeah, like
okay. So if it is a number, the program should determine if it is positive, negative, or 0 and display the appropriate message for each case. If it is a string, it should choose the number of characters. Oh, it should determine, I should say.
determine.
Yeah, determine.
So it's like the length.
Yeah.
Okay.
Yeah.
Mm-hmm.
Yeah, I'll fix that. But yeah, it should determine how many characters there were.
Okay. Okay.
Okay. Hey.
So in the midterm it asks for the program that uses weather data. Where do we get that data?
You should be able to download it. Didn't I put it in a link or? Oh, let me look at that because that's important. I thought I put it on campus. Okay. I sent you another file. The second one is Snake Game. Okay. So this is my version of the classic video game called Snake. And it has a lot of really useful code that you can take and borrow and do whatever you want with. All right, so let's take a look at Snake Game. All right, the first thing is I found this on a help blog in MathWorks. So the original code, I borrowed it from this website. You could probably still find the original code, but the first thing I did was I created a function. So I said, function Snake Game, right? And then I closed everything. So this kills all other variables that are open, right? And I start by asking the user a series of questions, right? So when you're thinking about your project and you're making this code, it's really good if you give the user enough instructions so they know how to use your program. Have you ever had a program that's really confusing, right? Ideally, you're going to give the user enough information so that they can do this, and it makes sense. Okay, so I say, welcome to Void Snake. Select your difficulty level. Okay, so this just determines how fast the game will move. Okay, and then do you want borders? Yes or no? So if they say 1, then there are borders. And then I ask for the map size, and it just makes a square map. Right? And I say axis limit equals input prompts. Right? So that's going to set the size of my window. Right? All right. Now, in my particular snake game, I created extra food that appears, right, that you can eat. So there's the classic version where you just have a one little piece of fruit and you eat it, and then you get bigger and the snake gets longer. And if you crash into your tail, then the game's over. Okay, so I said my starting point, right? This is X and Y. So my X position, I said the axis limit divided by 2. So it starts the user in the center of the video game. Right? And I said D equals 0. This is my initial direction. So I think it's going up. Right? And then here I use this variable EX because if EX is not equal to 0, it's going to exit my program. Right? So if EX becomes 1, then it exits the program. Right? And then down here, this is food. So this is my array of all the different food. Okay, so defines food for A and B coordinates. And so food is going to be a column vector. Okay, so all of my arrays in this are going to be column vectors. Okay, and you have a choice. Okay, because let's see, let's define snake. Right? So I said snake. Right? This is my initial snake. I want it to be 2 spaces long. And so that means I'm going to have 2 elements of my array. So when I play my game, right? Let's do snake game. All right, so 3, and I'll say, do I want borders? No. And I'll enter my map size of 20. Okay. So on my display up there, right, my snake has 2 sections. And so that means that I've got an array here, and my array is going to have 2 elements. Right? And each element in my array is going to have a coordinate. Right? So defines the snake for X and Y coordinates. Okay, so initially, snake will be, I'll say, snake of 1. So that's the first row. And then I'll say columns 1 and 2 are going to equal X and Y. So that's my initial position. So for the first element of my snake, it's going to be my starting position. Okay. But snake is going to keep track of where my snake is. All right. So as this thing is moving, I'm constantly updating the values in my array. All right. I'm going to press Q. So in my program. Okay. And so then I made a function here. It's called draw snake. And this function is what's going to display my snake. Let's say this will display my snake and update figure. Okay. Now this line here, this creates a figure and enables Matlab to monitor keyboard. Okay. This is my command. Figure, key press function at my callback. Okay, so this is a special syntax, and every time you go through the loop, it's going to check to see if there was an input there. So did you press a button? And it actually monitors the keyboard. And this is nice because if you want to make a video game, now you have the option to map any key on your keyboard into the program, and it will check for it. Okay. So the first one here, I say function my callback, and just copy this. Okay, splooge comma event, and then I've got my switch event dot character. Okay, so event is a has a property character, okay, and I'm going to give it different values. So the first case, the case Q. So that's Q on your keyboard. So if Q is pressed, it sets the variable EX equal to 1. That means that it's going to stop my program and return control back to the user. So if Q is ever pressed, set EX equal to 1. Okay, then case equals 30, and it says if D does not equal 2, right? Because this one is my arrow direction. And let's say if I'm moving up, D is going to equal 1. Right, so the variable D is my direction, right? And it says if I want to go down, D equals 2. So what's the point of the if loop here, or the if statement? I say if D is not equal to 2. What does that mean? Yeah, because in the video game Snake, okay, so let's run Snake again. Okay, so all right, so when my game is running, I'm going to start moving up, but it won't let me go down. I can't press down. So if I wanted to move down, I'd either have to go left and right first. That's right here. It says if D does not equal 2, because if the value of D is 1, that means my snake is going up. So the variable D always determines which way your snake is going. And the snake never stands still. It's always moving. Right? And so if D is equal to 1, that means the snake's going up. Right? And so I can't press 2, because if I press 2, right, case 31, that is case 31. This is a special character. This is the down arrow key. So 31 is the down arrow key, and case 30 is the up arrow key. All right, so this is nice because now we can not only can we use Q here, okay, now we can also use the arrow keys. Okay, so case 28, that's left. That's my left arrow key. So this is the left arrow key. Okay, but this is really powerful because now I can map any key on my keyboard into my program. Okay, it doesn't just have to be the direction keys. Maybe if I was making a shooter, right, I'd want to say, okay, R is reload, space bar is jump, and Q is recharge my shields or something. And then I could set W would be go forward. So I could do whatever I want. Right? And it doesn't just have to be arrows, right? Since I can map Q here, I could also play a sound. Right? So now I could turn this into a synthesizer if I wanted to. Right? Well, okay, so this is all before I get to my actual while loop. Okay, so let's see here. Okay, so this is a function, and it's my callback. Okay. So this end signifies the end of this function. All right, now I get to my while loop and I say, if EX does not equal 1, continue my while loop. All right, so the first thing I need to do is I need to say, all right, if 8 equals -1, hey, then I'm going to say snake. So size of snake equals empty brackets. Right? So if 8 equals -1, this means if I ate a black square, then I'm going to subtract something from the end of my snake. Right? So it's going to get smaller. All right, let's go ahead. Okay, let's get down here to this part. Okay, so here I said switch D. Okay, so this is going to determine which way my snake moves. Okay, so in case 1, I say case 1 is if D equals 1. Okay, then I'm going to add value of 1 to the Y position. All right, so let's think about what this is doing. Okay, so I say snake, snake of 1. All right, so here's my snake. Got my array. I say, all right, snake. This is going to equal, so we'll start off at position, let's say 3, 3. Right? And then the next one, if it's moving to the right, all right, so let's go back to my. All right, so case 1, add a value of 1 to the Y position. So this is going to be up. Let's see what D equals 1. Yes, if D equals 1, I'm going to move up. Hey, so I say snake 1, 2. Okay, so this is row 1, column 2. Right? And I'm saying I'm going to increase whatever my value is. Okay, so if my snake was at position 4, 4, and I'm going to increase this by 1, so I'll say snake 1, 2 plus 1. And so now my new position is 4, 5. Okay, so my snake is going to move up. So in my array snake, you know what? Let's in my while loop here, let's make the vector snake output to the command line so we can see what's happening. Oh, and I'm going to quit this. I'll say Q. All right. Okay, so where's my video game here? Okay, so here's my snake, and then these are the actual coordinates inside of my snake. So if I eat a green piece of fruit here, okay, now the program, right, now it has 3 columns. But in my array here, these are the current positions of my snake. So the first column, right, it's in, this looks like column 29, and then, oh yeah, so that's a row. Okay, so this is my, yeah, so on the right, those are my Y positions, and then this is my X position, right? And so if I eat the green fruit, Then I add another element to my snake array. Okay, now I've got 4 elements. And so I'm always, if I'm moving to the left, then my X positions are being updated. And if I eat a black piece of fruit, there, now I took one away. Okay, so basically what's happening is snake is an array, and each position in its body has a coordinate, and it's all contained in an array. Okay, so that's all for today.
Thank you, like and subscribe down below.